Welcome back to the White Dog Garage YouTube channel. I'm Bob, and this episode is going to be about tool repair. The job today involves my trusty little battery operated rattle gun impact driver. It's a 1/2-inch drive, so it's a really handy little thing. I got it some years ago. It's just a cheapo. I've got air tools here, which is my predominant use. But this is a really handy thing. You've got a vehicle in the driveway which you need to pull a wheel off or a couple of wheels off to sort the brakes or something. And it's easy to just go for this unit rather than kicking in the compressor and resorting to the air tool. Unfortunately, doing a job recently, I think I overexerted it and it broke away, which is a real shame. So the job today is going to be an attempt to fix this. I think it's an aluminium housing. I hope it's an aluminium housing. We'll see. If it's not fixable, it's not a great deal to replace it. I start by removing the anvil assembly from the broken housing. Followed by the rubber bump stop from the nose of the housing. I then undo the 4 screws that hold the base of the housing to the body of the impact wrench. The anvil rotates in this pressed-in bushing, but I don't think the welding will worry it, so I leave it in place. I think this and this has got to have a bit of a bath first before we go any further. I am using kerosene, also called paraffin, to clean the grease and dirt off the housing. I finish off the cleaning with the wipe down with acetone, paying particular attention to the broken edges. Fortunately, the crack is jagged, which means it will fit back together in perfect alignment. Aligned and clamped on the fixture table, I will use a burr in a rotary tool to gouge out a V into the crack area. I am using TIG welding to join the two pieces of the housing, and I start by tacking the joint in several places. You can see soot marks around each of the tacks, and this tells me the material has quite a lot of impurities embedded in it. I'm using a stainless steel wire brush to clean up the weld zone. So, before I add some filler rod, I use the torch to boil off some of the impurities. It all gets a bit hot and I stop regularly to let the housing cool off a bit. The TIG parameters, it's aluminium, so the welder is set on AC at 120 Hz. I'm using a foot pedal running between 25 and 80 amps. The shield gas, of course, is 100% argon, and the filler rod is 4043 aluminium. I'm not using pulse, as this is just a weld and fill operation, with the weld being cut back when finished. I still have some black flecks on the edge of the weld, but that's probably as good as it gets on this housing. I'll leave it all to cool off now before reshaping the weld area. Incidentally, the welding made the housing hot enough for the bushing to drop out. It's welded in a fashion. The thing I hate about old castings, particularly those that have been in contact with oil and grease, is that they're full of rubbish, and I have to spend a fair bit of time boiling out muck, I suppose is a good term for it. So I'm going to have to trim it up a bit. We've got full penetration there, you can't complain about that. I'm using a burr and a drill to remove the excess material on the inside of the housing. I am holding the housing in place using a bolt going down through the nose and one of the fixture holes to a nut on the underside of the table. Base down on the table, held again by a bolt going down through a fixture hole to a nut on the underside. I'm using a flap disc to rough down the outside of the housing. I'm using this file here, which is actually a panel beater's file for smoothing down metalwork. It has very wide serrations. Works very nicely on aluminium because aluminium can gum up an ordinary file very quickly. You can try a bit of WD-40, but I find one like this just smooths it down quite nicely, and that's what I've been doing. However, I've noticed a problem. There's a hole there. I always knew there'd be problems, and I spent some time trying to boil out the impurities. Anyhow, it all looked good. I overfilled everything, of course, which is, I've had to do a bit of work to get it all back down to normal again. But in grinding or filing away the overfilling, I suddenly developed this hole, and I'm going to have to fix that. And it's just a quick weld job really, but I will clean it out with a burr first and go from there. Having opened up the hole, I am using a piece of copper as a backing strip to the weld area. So it's a relatively rudimentary clamping arrangement. I've got the backing strip in there, held in place with these vice grips. I've just got a G-clamp holding the nose cone onto this steel block, which gives it a solid surface. And I will just re-weld that area there. You can still see a lot of black specks. I think I'm going to leave it at this. It doesn't have to hold oil or anything, it just holds grease which won't come out. With the welding repair done, I am ready to put this impact wrench back together. There's a bushing that goes in there, in the centre. This is it here. But there's an O-ring that goes in between it and the end. Just giving it a light coating of rubber grease. Push it down. Make sure it's seated properly. Now the bearing is a press fit. It's not going to go down with my fingers, and we're going to use the press. Using the arbor press gives you a lot of control over the process. With the bushing lined up, I use the press to slowly push it in, ever alert for any jamming on the way down. And it slides in relatively easy. There's another O-ring, this one here. I give it a bit of love as well. Just sort of lube it up, and we will drop this one. Before I refit the housing, I apply grease to the surfaces of the impact mechanism and the anvil assembly. On this tool, the housing only fits in one orientation. The screws are not evenly spaced, which is a great help because I never took any notice at all when I disassembled it as to which way the nose piece went. And what I found in checking is that it's only goes the one way. So all we need now is a screwdriver. The screws are self-tappers going down into a plastic case, so I am screwing them in manually using a screwdriver rather than reaching for an impact driver. Finally, the rubber nose piece is refitted and the impact wrench is ready for use. So that brings us to the end. I had thought about replacing it. The problem you have with battery tools is that you need to keep in mind your battery ecosystem. That's a neat little term, isn't it? It's the batteries that you use, which are interchangeable between tools. This one's an orphan. I have no other batteries that match this one. My main professional set is Bosch, but the Bosch one's getting pretty old. I haven't had to buy any batteries, but I have got one battery that's a bit iffy. I have been looking at Milwaukee, Big Red. I was working on a truck recently, and another chap there that was working with me, he had a nice Milwaukee rattle gun, and gosh, it was a nice machine. And you know, when he managed to drop it on the ground, it bounced very nicely and still kept on working, and that's the main thing you want, I think. Anyhow, thanks again for watching. I look forward to talking to you next time. Bye.